Okay, so this is a follow-up to solving linear simultaneous equations by elimination. So I'd recommend you watch that first as it gives you a bit of a background to simultaneous equations. Let's go! So essentially, elimination is not the only way to solve simultaneous equations. We have a method that we can call substitution as well. And it's called that because you take one equation and you substitute it into the other equation, hence the name. Let's look at these two as examples of what we can do. So we've got an equation here that t equals 3x plus 7 and x equals t minus 11. And what we're going to do is we're going to take this and we're going to sub it in where there's a t in the other equation. Okay, we know t is equal to 3x plus 7, so that means we can replace any instance of t with a 3x plus 7. So let's actually do that. We'll end up with x equals 3x plus 7 minus 11. Okay, why do we do this? Well, that's got rid of t immediately without having to do that complicated multiply up and subtract stuff. And this is just a linear equation that we can solve. We can go x is, so we do 7 minus 11 is minus 4. And then we would add the 4 across the other side, I guess. So we'd say x plus 4 equals 3x. Take away the x, we'll end up with 4 equals 2x. I guess I should be writing down what we're doing here. So we've added 4 and then we minus x. And then we would divide by 2 and we'd end up with x is equal to 2. So we haven't really had to consider the simultaneous side of it at all. Now we then want to get what t is. Don't forget we need to solve both these equations and we can use the top equation 3x plus 7. We can go this is 3 lots of 2 plus 7, so t is equal to 13. We could, of course, check that this works if we wanted. From the first equation, 13 equals 3 times 2 plus 7. That's right. And the second equation is telling us that 2 equals 13 minus 11, which is right as well. So yeah, that's the general idea. We sub it into the other thing. So what would we do with this second one? We could actually do a couple of things here. We've got an expression for b. So one option would be to put this in place of b. And the other option would be to put this in place of g. So let's actually do both of those and just show that they will give you the same sort of idea. So in the first one, we're going to substitute this in place of g. So that would tell us that b is equal to 2 lots of, now it's not just g, but it's 2 lots of 3b minus 4 minus 27. And then from there, you obviously have to expand. So we get 6b minus 8 minus 27. Simplify a little bit, so 6b minus 35. And then we probably want to go through the same thing we did before. So we're going to add 35, we're going to take away the b, and we're going to divide by 5. So let's just see how that works out. So b plus 35 is 6b, 35 is 5b, and divide, and we'll end up with b is equal to 7. We could then substitute that back into the top one. G is 3 lots of 7 minus 4. And remember, I'm getting this from here that G is 3b minus 4, so I'm just substituting that back in. 21 minus 4, so G is equal to 17. So that's one option. We could have put the 3b minus 4 in place of the G. But we could have also, as I said, take the 2G minus 27 and put it in place of the B, because that's B is equal to 2G minus 27. So how would that work? We'd get G is 3 lots of 2G minus 27 minus 4. So then do the same thing as we've been doing, expand that, so 6G, a little bit similar looking, but we'll try and remember that's a G, minus 81 minus 4, collect our terms, so G is 6G minus 85, and then the process we're going to go through this time, I think, is to add 85 to take away G, and then to divide by 5. So we'll end up with G plus 85 is 6G. 5G is equal to 85, and then if we divide through, we'll get G is 17. And then if we want to get B, we'll substitute that value of 17 into the bottom equation. So B is 2 lots of 17 minus 27, which is 34, minus 27, which is equal to 7. So in both cases, we end up with B is 7 and G is 17. Doesn't matter which way round you do it. So that's the general idea. Now, something that you might need to do is rearrange your equations first. We kind of want one of the equations to say y equals this or k equals this, so we can put it into the other equation. So like with this first one, our first step would be to rearrange this into either y equals 12 minus k, or we could go with k equals 12 minus y. It doesn't really matter which. Let's use y equals 12 minus k though. We've got that obviously by subtracting the k. So we'll write that directly beneath it. Y equals 12 minus k. So these are our two equations. And what we're going to do is we're going to take the fact that y equals 12 minus k and put it in place of the y that's there on the other side. So let's do that. We'll end up with 3 lots of 12 minus k is equal to 2k plus 3.5. Expand. 36 minus 3k is 2k plus 3.5. And then we can do sort of our collecting terms. So I think we're going to add 3k to both sides, and we're also going to take away 3.5 from each side. So I'll end up with 36 minus 3.5 is 2k plus 3k, which gives us that 5k is 32.5, which is good. We can divide by 5 there, and you can have decimals in a simultaneous equation. That's okay. We'll end up with k is equal to 6.5. You then got a choice about what you put that into, but let's use the easy version that we've got. Y is 12 minus k, so y is 12 minus 6.5, which is equal to 5.5. And we could check it works if we wanted, but you're going to have to take my word for it on this one. Okay, and then for the second one, one way to rearrange it, if we could rearrange this and make this into b equals something, or we could rearrange this and make this into a equals something. It's completely up to you how you do it. I think the easiest one is this because it only requires moving one thing across. So I would rearrange this into b equals, and then take away the 4, 5a minus 4. So we're going to take that 5a minus 4, we're going to swap it or substitute it in place of the b, and we'll end up with a plus 4 lots of 5a minus 4 plus 5.5 equals 0. And then it's the same as what we had before. It's a linear equation to solve, so we just need to expand that. That's 20a minus 16. Collect our terms together, 21a minus 10.5. And then, a little bit easier than the ones we've had, we're going to add the 10.5, and then I think we're going to divide by 21. So we're going to end up with 21a equals 10.5, and divide by 21. That's going to give us 0.5, or half if you're a fraction person. Then substitute that into the fact that b equals 5a minus 4. So b equals 5 times 0.5 minus 4, which is 2.5 minus 4, which is minus 1.5. Again, we could check this one works if we want. Let's actually do it this time. So we could say 0.5, and then what would 4 times minus 1.5 be? That would be minus 6, plus 5.5 equals 0. Yep, that's true. That would be 6 minus 6. And then the first one, 5 times 0.5, so 2.5 is equal to minus 1.5 plus 4. Yeah, that works as well. So that's the general idea. Okay, so for these last two questions, I'd like you to have a go first using the methods and techniques that we've looked at. Unpause the video when you're ready for me to go through them, which will happen in 3, 2, 1. Okay, so for this first one, I would probably want to take 2j minus 2 and substitute it in place of r in the top equation. You could rearrange the top one to j equals something and substitute it into the bottom equation, but that's more steps, and I am very much against doing more steps for the sake of it. So let's substitute that in. We would have j plus 3 lots of 2j minus 2 is 29. And then we've got to go through the normal procedure of expand our bracket. Done. Collect our terms together. Done. And then we want to make j the subject, obviously. We're going to need to add 6, and then we're going to need to divide by 7. You don't need to write that on the side ahead of time. I just don't like changing pen color too much. So we'll end up with 7j is 35, and j is 5. That's a nice whole number value. That's always promising. To get value of r, we then substitute that into the fact that r is 2j minus 2. So it's 2 times 5 minus 2. So r is equal to 8. We should check that works. So according to the top one, 5 plus 3 times 8 is 29. That's true. And for the bottom one, 8 is 2 times 5 minus 2. That's true as well. Excellent. Second one, you do have to do some rearranging. Now, I think the easiest thing to do is to take this first equation and just multiply it by 4. If I do that, then I'll end up with p equals minus 4 minus 12q. So that's the equation that we're going to use. And we're going to substitute that into the top equation. And you're going to have to be careful with signs, basically, on this. This is about as tricky as I think we can put together. So we're going to substitute in that p is equal to minus 4 minus 12q. That'll give us 3. Lots of minus 4 minus 12q. Minus 2q is equal to 64. Expand this, we'll get some negatives, so we'll end up with minus 12 minus 36q minus 2q is equal to 64. Okay, collect our terms, so we can collect the minus 36 and the minus 2 to give us minus 38. And then we want to make this the subject, so actually, well, let's try adding 12 first. That'll get rid of our minus 12 over here. And it will leave us with minus 38q, remember that minus doesn't go away, is equal to 76. And then we want to get just q on its own, we're going to have to divide by minus 38, which will obviously flip that sign to being positive, to being negative. So we'll end up with q is minus 2, which is positive, well, which is whole number, so that should be okay. We then want to substitute that into the equation that we've got here, that p is equal to minus 4 minus 12q. So minus 4 minus 12 times minus 2. So that would be p is equal to minus 4 plus 24. So p is equal to 20. Again, we should probably check that that works. So for the top one, we're saying 3 times 20 minus 2 times minus 2 is 64. And that would be 60 plus 4. So yeah, that works. For the bottom one, we're saying 0.25p, so 0.25 times 20, which is a quarter of 20, which is 5, is equal to minus 1 minus 3 times minus 2. So minus times a minus is positive, so it's equal to minus 1 plus 6. Tick. That last one was a bit tricky, eh? So this is the last sort of point I want to make here. I'll just rub some stuff out of the way. That a question in an exam is not going to say use elimination or use substitution. It will just say solve this simultaneous equation, and these are just two different ways you can approach it. The reason that we're introducing substitution is that it is by far the easiest way of doing quadratic simultaneous equations, which is the next thing we'll look at. Cheers.